so today we're starting our last conic section, which are hyperbolas. Hyperbolas are going to be kind of similar to our ellipses in their definition and also in the equation. But there is going to be kind of a key difference. So our hyperbola is going to be the set of all points where the difference of the distances to two fixed points is constant. So the big key here that's different than our ellipses is going to be that it is the difference. And because it is the difference, basically what we do is we take our ellipse, we cut it in half, and then we reflect it. So it's kind of like two halves of an ellipse that are not facing each other, which means that we end up with parabolas now instead. So on this first one, it's just kind of showing you what D1 and D2 would be and that we would subtract them and that we end up with the same thing. Now, just like before, we do have our center is going to be in the middle. We have two vertices and they lie along our transverse axis. So our transverse axis is kind of like our major axis. It just has a different name when we're talking about a hyperbola. Our distance from the center to the vertex is still going to be A. And the distance from the center to the foci is still going to be C. But if you notice, we do not have which term this time? A B value. There's not really a B value on this. Now, what our B value is actually going to do is it's going to create some asymptotes that are going to determine how wide or narrow our graphs are. So here is the equations for our standard forms of our hyperbola. So notice that my center is still at H, K. The vertices, like we said, are A units from the center, and the foci are C units from the center. And now, this time, we still have a relationship between A, B, and C, but notice that it is slightly different because we would have a slightly different right triangle for our hyperbola. So now it's going to be C squared equals A squared plus B squared, which is different than our ellipse because what was it for our ellipse?
C squared equals A squared minus B squared.
Yeah, it was minus B squared for our ellipse. Okay. Then also, like I said, notice the big difference in our standard form equation is that we have a subtraction sign here. Okay? When we're talking about a horizontal horizontal hyperbola, we're talking about something that opens to the left and to the right. When we're talking about a vertical hyperbola, we're talking about something that opens up and down. So which one of our variables is the positive variable for our horizontal or left and right hyperbola? So for our horizontal hyperbola, left and right, which one of our variables is positive? So transverse axis is horizontal, right? Which means that we're opening left and right. So it's that first line. Which one of our variables is positive or does not have the subtraction sign in front of it? I need more confirmation. Do we all see that my x is the thing that is in my first term or first fraction?
Yes.
And that it is positive?
Yes.
Okay. We're all really, really quiet, and that worries me. So, that means if I have a vertical hyperbola, which one is positive for our vertical hyperbola? Why? Are we all alright? Because that's going to help us, and that's what we're going to have to look for, because we need to know which one of these equations we want to use when they give us certain information. So we have to know that if my stuff is horizontal, I'm going to have my x's be positive. If my stuff is vertical, my y's are going to have to be positive. Yes? Yes.
Can you go back to the other slide so I can take a picture of it?
Yeah. Alright, so let's look at one more definitions. Like I said, we have asymptotes. Our asymptotes are going to determine how wide or narrow our hyperbolas are. Okay, and they use these equations. Now, I will say, we don't use these equations like super often, okay, but I will give them to you. So if by chance you do need them, you at least need to know how to use them. Okay, so let's look at an example. This says, find the standard form equation of the hyperbola that has foci at -1, 2, and 5, 2, and vertices at 0, 2, and 4, 2. So what might it be helpful to do? Draw a picture. Draw a rough sketch. Yes. So where are my vertices going to be located? Where's the first one located? 0, 2. Which is where? On the y-axis. On our y-axis. And then we would also be at 4, 2. Now, our foci are going to be at -1, 2, and 5, 2. And if we refer back to our pictures, where do our foci have to be in terms of our parabolas? They have to be inside of them. So our foci are going to tell us which direction we open. So if our foci have to be inside of our parabolas, which direction are our parabolas going to have to open? Left and right. So that tells us that we're going to use which of our equations? Or which variable is going to come first? The x's. So we would have x minus h quantity squared divided by a squared minus y minus k quantity squared divided by b squared equals 1. So can we find any of those things from our picture so far? Yes, no, yes.
We could find the center distance.
Yeah, so we need to know our center right before we start finding anything else because our A's and our B's depend upon our center, yes? So how could we find our center?
Distance formula.
Not the distance formula, but the midpoint formula, because remember that our center has to be in the middle, right? Of which 2 points?
The vertices.
Or, yeah, you just need to make sure that I use both my foci or both my vertices. It doesn't matter which one. Just don't use like one vertice and one foci. That won't give us anything. So I'm going to use my vertices. So remember that it's x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So what do we get? 2, comma, 2. Which makes sense because that would put us in the middle. So now that we know where our center is, what does that give us?
H and K.
Yeah, so it gives us H and K, but it will also help us find A and C. So I can go ahead and plug in my H and my K. Now remind me, what does our variable A represent? The center and the vertex. So now that we have our center, this is going to be A. So what is that going to be? Or what's the different distance from 2, 2 to get to 4, 2?
2.
2. Or to get from 2, 2 to 0, 2 would also be 2. So then what's going to go underneath our x? 4. Okay. Now, what did we say that our B determines? What does it give us?
Distance from.
What does our B give us? Our asymptotes. Thank you. Do we have our asymptotes on here? No. Okay. Now, do we have any other information on here, though? What do we have?
Okay.
The foci, okay? And what variable can we find from our foci?
C.
Our C value. So what is our C value going to have to be in this case?
3.
Alrighty. Now, do we have anything that if we know A and C that would help us find B? That formula, yeah. So C squared equals
A squared plus B squared.
right, so then we could plug in. So we would have 9 equals 4 plus B squared. So B squared equals 5. And then I plug that in for B squared. So that would be my answer. Questions on any of that? That's where I got it from, how I labeled things.
So if you don't ask for the asymptote, you don't use your own.
Correct. I would. doesn't ask for the equations or like ask you to actually graph it. So realize that that's not a super accurate graph because my asymptotes are what determine how wide or narrow it was. I was just using a rough sketch. Now if they actually say graph it, and we're gonna look at that in a second, we would have to draw our asymptotes.
So how wide or narrow the hyperbolas are, or how close or far away they are?
Now how wide or narrow the actual like parabolas are. Does that make sense?
Yeah.
So it's kind of like if you think about like your quadratics, remember it's like the a value. That's how it makes it how wide or narrow the parabola is. Well, let's go ahead and look at an example of that. So we're going to graph it. Now, they give us 4x squared minus y squared equals 16. Can we graph that? As it is?
No.
No, because what? Because what? It's not in standard form. Yes. So we can't graph it right now because it's not in standard form. But what do we notice about our equation? It's not equal to 1, and that's going to be important here in a second. What else do we notice? How many terms do we have?
3.
On the left-hand side. 2 terms, right? And both of those terms are being squared. Now, think about normally when we have to complete the square, how many terms do we have? 4, right? Because usually we have an x squared, a y squared, but then we also have like an x and a y. Because remember, the x and the y are what give us our b values to be able to complete the square. Well, if we don't have an x or a y, are we going to have to complete the square? No, because your b value is 0. 0 divided by 2 squared is still 0, so we don't need to add anything. But like Kate said, we do have to make sure it's equal to 1. Right now it's not equal to 1, so how do I make it equal to 1? Divide everything by 16. But remember, we want to write these as fractions, so I would have 4x squared divided by 16 minus y squared divided by 16 equals 1. And then we want to simplify that first fraction. So how many times does 4 go into 16? 4. So what is our a value?
2.
What is our b value?
4.
Is it okay that our a is smaller than our b?
Yes.
Yes.
Yes, because we have a hyperbola, not an ellipse. If I had an ellipse, would it be okay that my a is bigger than my b?
No.
No, because for ellipses, your a does have to be bigger than your b. Are we all with me? So where is our center?
The origin?
At the origin. That's nice. So we're going to draw our center at 0, 0. And we first want to draw our vertices. We have to think, okay, are our vertices going to be up and down or left and right from our center? So what are they going to be? So how do we determine if it's up or down or left and right? What are we talking about? The x is in front. The x is what's positive, yes? So that tells us that it's going to open which ways? Left and right, which means that our vertices also have to be left and right from our center. Are we all with me on how I kind of went through that process? Okay. And they specifically have to be 2, because that's our a value, units away, both to the left and to the right. Now, like I said, because they actually asked us to graph this time, we need it to be accurate, which means that we need to figure out how wide or narrow our parabolas need to be, which means that we need to graph our asymptotes. So there's 2 ways that you can do this. One, we can use the formulas that they gave us and write out the actual equation and graph the line. We all know how to graph lines. They're in point slope form or point intercept form, whichever one you want to graph it in, and then you graph it. Or the way that I prefer, so it doesn't necessarily make it the right way, it's just the one that I think is the easiest, but like I said, you can do either one, is the box method. So what our box method does is I use my vertices, so as my first 2 points, then I'm going to take my B value, and I'm going to go up and down that many, and create 2 more points. And then it's called the box method because I'm going to draw a box using those 4 points that we have. And then our asymptotes are going to be created by making 2 lines that go through the corners of our box that we created and the center. So that would be one of my asymptotes. And that would be the other asymptote. Do y'all see how I got those lines? Yes. And you would get the same lines if you graphed them by hand by creating the equations that we saw on the previous page. And then remember that because these are asymptotes, my graph is going to get closer and closer towards them, which is why it determines how wide or narrow it is. So that would be our graph.
So on the test, we could do the box method, like draw
Correct.
it to show how it works.
Yep. Other questions? Now, sometimes if it just says what is the equation of the asymptote, then you would actually have to find the equation. But if it doesn't ask you to find the equation, then you're fine with just using the box method. Yes.
How did you get the center like that?
0, 0? Because I don't have an h or a k that I'm subtracting on the inside of my square. Remember that it's like x minus h quantity squared, y minus k quantity squared. We don't have either one of those, so that means they're automatically 0.
Okay.
Good question. Other questions? Yes, no? Alright. Continuing on then. Alright, what's different about this one? Again, they ask us to sketch the graph. Yes.
We would have to complete the square with 4x squared.
Yes, so we are going to have to complete the square with our x's. Why don't I have to do it with my y?
There's no second value for y.
Correct, I don't have a y term, so that means I'm only going to have to complete the square once. Alright, so I want y'all to practice completing the square. Let's put this in standard form. Divided by 2. So it could be divided by 2.
C value?
B divided by 2
No, you got.
squared. So it's still like, yeah. In this case. Here's not anything. So you don't have to put this right, so it's just going to stay. What else do you have to do? Not yet. Remember whatever. You add 4, right? So I have 4.
I got
Do you have a 2 square?
That's 16, so.
You have to like add 16 together.
But then 1 factor that. So right now it's a perfect square.
No, it's original.
And then you're going to have to divide everything by.
Yeah, this is what I did. This is what I did.
Yeah, it's just one.
Okay, so remember that our a equals to 1, we're going to have to factor out a 4.
So then
X
it's
squared minus x. And then it's minus 3y squared. I would do it first. No, but when we move it over, we have to subtract
so
the
then
negative. So then we're going to have to figure out the inside.
I was thinking, I don't know. So it's something to do with taking these two numbers and then making it so when you subtract it also. Does it work?
And so with them after the multiply together, you can do it.
Wait, hold up. Let's do that. So we just have to factor
But they have to be the same number, right? That added with
You think like 16?
x, well, then that means you can combine that by dividing this.
So you will.
And then you would square it. But then, well, it would be 1, so it's good. And then you add. It's still in the parentheses.
So like just the shells.
You have to.
Wasn't there a cell like just the shells not out? So like,
And then we have
No,
to.
I like
it's a sugar shell.
So we added 1 here, but when it's 4.
I'll try so one 16.
I mean, yeah, like buy
And then
and haul them out and resell the shell.
So then it would be
We should just have it a lot of time.
And then you would factor. So
I think I'm the only one
so
who
what
buy
is x squared plus 2x?
You like the shell more than chocolate.
I think so.
No, I don't know. I actually
You can't distribute that one. So
Oh
remember,
wait,
we're
okay,
factoring-
factor, not distribute.
church like one
So if we're
chocolate
saying
cake maybe, that's why it's
we're saying
kind
what
of
multiplies together equals 1, and that's the same thing.
so most of the time like on the inside.
And then you can
B over 2 squared. B over 2 squared.
Two squared?
B over 2
One,
squared.
so the
x plus 1.
Where B is 1, the second x. So x that is the square.
I like to like fight along the
So,
seam.
no, that's
By your name.
You talked about before.
Peanut butter or bacon, yeah.
Wait, B over 2 squared.
Like extended.
I've done
B is
4.
1 squared. Yeah, B is 8. So, 8 divided by 2. No.
Divided by 2 squared,
Yes.
I would know yours.
X
But I would leave yours that way.
8 divided by 2 is 4. Because it's 2
No, wait,
squared.
wait,
So,
When you factor out what you're doing.
B divided by 2 all is squared.
So.
Quantity.
Oh,
As I said.
This way, so we factor out 12.
There you go.
Except you have 4.
Yeah, that's all I need, right?
B would be 8 divided by 2 would be 4. 4 squared is 16. So that's the number you need to find.
Then if we have anything, like we have a lot, that
And then I bought it like in 3 times.
Then remember, we
I
want
know it doesn't count. Yeah, I remember.
Yeah, but I wonder if
We're gonna add 1.
I'm facing.
So you know how you add 16? don't have to do anything.
You know which quotient is right. You told you corner, don't you?
Check, yeah, yeah.
And then divide by four.
So I'm just doing 3 and then
And divide the add right.
Yeah.
Wait, okay, so I got.
Alright, so let's go ahead and look at this all together. So remember that our first step is going to be to just rewrite it so that my things that have x's are together and my things that have y's are together, and then I'm going to move the 16 over. Remember that our a value has to be 1, so I'm going to factor out my 4. I don't have to worry about anything with my y because we don't have a y term with it. So our b value is just 0, so we're not going to have to complete the square with that one. So then for the inside of my parentheses, I'm going to have to do our b divided by 2. So 2 divided by 2 and then square it, which is still 1. And then I also have to add that to the other side. So be careful because remember the 4 on the outside of our parentheses affects our 1, so I actually have to add 4 to both sides. So then the whole point of completing the square so that we can write our x's as a perfect square. So we get x plus 1 quantity squared. And then, just like before, we need our equation to equal 1. So I'm going to have to divide by a negative 12. But notice that a negative divided by a negative is going to become positive. And then I just want to simplify. So 4 goes into 12 3 times. And 3 goes into 12 4 times. But notice that since my signs have now flipped, I also want to flip the order of, that should be a 2. I'll fix it in just a second. Of my variables. So that would be my final equation. So questions on any of the completing the squared steps? Because next up, we're going to have to graph it and find the equations of some things. So, what is our a value this time? 2. What is our b value? Square root of 3. Now, since they ask us to find our foci, what are we also going to need? The c value. So we're going to use our equation, c squared equals a squared plus b squared. So we get that c equals the square root of 7. Okay. Are we all okay with how I found those values? Yes.
Why do we have to flip them again?
Because we want our positive one to be first.
Okay.
So notice that when I divided everything by a negative 12, it flipped the signs. So then we want to rewrite it so that the positive one, which is now the y, comes before the negative one, which is the x. Yep. Alright, so let's start graphing some stuff. What is our center going to be? Agreed. Okay, and then if I wanted to find our vertices, are we going to go up and down or left and right this time? Up and down, because our y squared is first. And how far up and down are we going to go? Nope. Because our a value is 2, so we're going to go up and down 2. Now, our c value is what's going to give us our foci, correct? So what is our c value approximately?
square root of 7?
No, like what is the square root of 7? Approximately. Gonna be between 2 and 3, right?
2.645.
Okay, so 2.6-ish. Okay? So for my graph, that's all I need. So I'm gonna go up 1, 2, and then a little over half, and then down. And a little over half. Okay? But how would I write, because it actually asks us to write out the foci, how would we write that as a set of points? So if I'm going up and down from my center, am I changing my x value for my foci from my center? Do we all see what I'm talking about? If they all line up vertically, they all have to have the same x value. Agreed? Okay. So then if I have a 0 here, or if I have any number there, I'm either going to add or subtract it from my original y value, if I'm going up and down, with my c value, right? So we would add the square root of 7 and subtract the square root of 7 from 0 in this case. So we just get square root of 7 and negative square root of 7. Are we all okay with that? So our 2 points would be -1, comma square root of 7, and -1, negative square root of 7. If I had a number there, like 2, we would just write 2 minus the square root of 7. Are we all okay with that? Yes? Okay. So then, what do we need to find? The asymptotes, okay? So, we can do it one of two ways. We're going to have to find the equations. But if we still just wanted to graph it doing our box method, we could. But we need to know what our b value is. So what is the square root of 3 approximately?
1.7.
Okay. So that's how far left and right from my center I'm going to go. And remember that I take those 4 points of my vertices and my new b value points to create our box and create our lines. Okay? And then this time, we're opening up and down. So we're not quite stretched as far as we were this last time. So if it just asks us to graph it, I would be done. But it does ask us for the equations as well. Agreed? So we need to actually write out the equation. So we have y equals, and what did our equation give us? We're using this one, right? So it's going to be k plus or minus a divided by b times x minus 8. So k plus or minus a divided by b times x minus 8. And we use the a divided by b because it's vertical. If it was horizontal, it would be b divided by a. Yes?
Okay, so technically, if you did see that it was like the asymptotes, so that you could do the y equals mx plus b thing, could you do that?
You could. The only problem is that because your b value is the square root of 3, notice that like most of these points aren't going to be exact, right? So like you'd be ending up with decimals, and so it would be hard to write it in y equals mx plus b because you're going to have to approximate things. Does that make sense? Now, if you had all whole numbers, then yeah, totally. You could say, okay, this is my intercept. Oh, here's another point, and write it out that way. But if I plug in all of my stuff, my k value, notice, is 0. So we would get plus or minus our a value, which is 2, divided by our b value, which is the square root of 3 times x plus 1. And I would be okay if you left it like that. So they asked us for the foci, so that's one of our answers, and the asymptotes. So those are it. And then we have our graph. So we need to look at our last example for our hyperbola stuff. So on this one, they ask us to find the standard form of the equation of the hyperbola having vertices at 3, -5, and 3, 1. And this time they give us our asymptotes, which we can also see in the figure. So the first thing that we need to notice is that this is an up and down hyperbola. So remember that if it's an up and down hyperbola, then our y is what's going to have to come first. So y minus k, quantity squared, divided by a squared, minus x minus h, quantity squared, divided by b squared, equals 1. And then the big thing that we need to find first is going to be our center. We'll notice that we could use our midpoint formula if we needed to, and we could see, okay, 3 plus 3 divided by 2 is still going to be 3, and then 1 plus -5 would be -4, which would be divided by 2 would be -2. So this point is going to be at 3, -2, which is nice because remember, that's going to give me my h and my k value. So then the next thing that we can find pretty easily is going to be our a value. So remember that our a value is going to be the distance from our center to one of our vertices. And in this case, I am going up and down. So we should see that this is going to be a distance of 3, which means that my a squared is going to be 9. Now, notice that they don't give us foci or basically anything else. They only give us our asymptotes, which means that we're going to have to use those asymptote equations that we had on the previous page. So remember that when it's an up and down, it's going to be y equals k plus or minus a divided by b times x minus h. Remember that it's a divided by b when we're vertical and b divided by a when we're horizontal. And since I have most of the other stuff, I can go ahead and start plugging in. So we know that our k value is going to be -2. Our a value we found to be 3. Our b value is what we're looking for. And our x value is going to be 3. So then we kind of want to start simplifying this as much as we can. So I'm going to go ahead and just work with one of the equations at a time. So I want to look at y equals -2 plus, just because it's going to be a little bit easier to look at the positive one, 3 divided by b times x minus 3. So now notice I have a parentheses here. In the two equations that they gave us for our asymptotes, neither one of ours have parentheses. So we are going to want, notice that neither one of our asymptotes have parentheses. So we need to get rid of our parentheses in the equation that we have in order to be able to kind of match and see which one we need to look at. So I'm going to go ahead and distribute that 3 divided by b. When I distribute it to the -3, well, 3 times -3 gives us -9, and then we would still have divided by b. And so then I'm going to rewrite it a little bit. So I'm going to have 3 divided by b times x minus 9 divided by b minus 2. Now there's some important things to point out. So remember that B represents distance. A represents distance. And so if A and B represent distance, then they must be positive. So we know that B is positive. Well, if B is positive, then we know that 3 divided by B must also be positive. And that's important because notice that only one of my equations has a positive number in front of the x, and that's going to be the y equals 2x minus 8. So if that's the only positive one, and we have 3 divided by b in front of our x for the equation that we wrote, we know that whatever b is, we have to end up, because they told us that that is our asymptote, we know that our 3 divided by b has to end up being 2, because that's what's in front of the x. So then we could solve for b. So we would multiply both sides by b, and then divide by 2. So we get that b equals 3 halves. But remember, when we have our equation, we're looking at b squared, so we could square both of those separately. So we would have 9/4. So we could plug in 9/4 here. Most of the time, that's not how we're going to write it. So think about if I had 9/4 and I wanted to multiply by the reciprocal, right? So we have something divided by 9/4. We're going to have that something, and we're going to multiply by the reciprocal. So if we kind of think about that the same way for our equation, notice that we would have the 4 in front and the 9 at the bottom. And that would be our final equation.